Welcome to the test set. Here we talk with some of the brightest thinkers and tinkerers in statistical analysis, scientific computing, and machine learning, digging into what makes them tick, plus the insights, experiments, and OMG moments that shape the field. In this episode, we talk with Trevor Manz. Trevor started out in chemistry and computational biology before moving into visualization research, where he ran into a problem. Researchers could build these sophisticated tools, but getting them into the hands of people analyzing data was another story. That frustration eventually led him towards Python notebooks and to creating anywidget, which makes it easier to build interactive tools that work across the computational notebook ecosystem. Today, he's a founding engineer at Marimo, where he's pushing that idea in a new direction. If notebooks are such a useful place for humans to explore data, could they also be a better place for AI agents to do it? And what would AI agents need to use notebooks effectively? We're joined by self-proclaimed notebook skeptic Hadley Wickham, which I think makes for a fun discussion. So with that, Trevor Manz. Trevor, welcome to the test set. So you're Trevor Manz, scientist, programmer, and as you say, Wisconsinite, which I'm excited to dig into. You created anywidget and you're a founding engineer at Marimo. Yeah, thanks for coming on. So happy to have you.
Yeah, thanks so much for having me.
Mm-hmm. And by way of introduction, I guess I'm Michael Chow, the host of the test set, and this is Hadley Wickham, co-host and chief scientist at Posit. Yeah, Trevor, I'm so excited. I know you've been doing a lot with Marimo and notebooks, and especially with Marimo Pair. I'm so curious to talk a bit more about Marimo and notebooks. Maybe just to kick it off, you could explain a little bit about what Marimo is and kind of like who uses it and what excites you about it.
Yeah. So Marimo is like a new kind of...
I'm so sorry. Yeah. My bad.
Yeah, so Marimo is a new kind of Python notebook. And I like to describe them as a delightful reactive Python notebook. And the first piece is that we're a delightful notebook insofar as that we've been able to look a lot at how notebooks are used in practice and then really think about creating a very built-in user experience for many different ways that notebooks are used, like traditional notebooks are being used. And then the second piece there is that we are a reactive notebook. So similar to observable notebooks or Pluto, which are sort of from the Julia ecosystem, Marimo does not... Marimo understands the relationships between your cells, not based off of the ordering that you wrote the cells, but the actual data flow. So where your variables are declared and how they're used to find the execution order of your notebook. And that leads to eliminating this kind of hidden state that can come from having sort of a traditional Python REPL or like a traditional Python notebook. And then the third piece is that we're a Python notebook. So we're like only focused on Python. And that is all the way from a lot of the user interfaces oriented around data structures that are in the Python ecosystem. We have things like a built-in package manager. So for when you're trying to work on your data, we can install packages for you, all the way down to the file format itself. It's not like a JSON file. It's actually a Python script. So yeah, those are the three things I think that sort of characterize Marimo in contrast to other sort of computational notebooks.
Yeah, awesome. And I appreciate you helping with the pronunciation. I feel like this also came up at PyCon when I saw y'all, that this is the perfect chance that I'm going to work Marimo in and Marimo out forever. So I'm glad that we have this to practice. But
happy to help out there.
Yeah. It's interesting to hear too, you mentioned like as a package manager and some of that, like maybe the surprising scope of things that kind of enter in to a notebook. Like if you want to be delightful and useful, that even it sounds like package management kind of becomes an important piece.
So we like to say that Marimo is like we're an open source computational notebook that's used across like industry research and education. And then beyond that, I think as well, from being able to look at the different ways that people are trying to use traditional notebooks, we've also thought a lot about, you build up a notebook, but like, what are the directions that you might want to take it? So some notebooks look more like doing like data pipelines, and those you can run as Python scripts and maybe have very few visual elements. There's some that maybe are more in this world of like literate programming, where it's both like your code is very forward, and then you have prose explaining and contextualizing the code. And then we have, because we're a reactive Python notebook, the cells can react to user interactions. And so there's a mode within Marimo that we call like app mode, that you can just hide all of your code and then you just have the outputs. And so for that set of users, it's more like presentational, or, showing people almost these like data apps, but without having to show the code. And I think it's quite hard to like generalize like what that user group is. But I think if I could generalize it, it would be, individuals that are not professional software engineers, but have traditionally learned a little bit of code to do something with data.
And do you think, is it like mostly like data people broadly construed, or are there people doing like non-data stuff with them as well? I'm sure there are people doing non-data stuff, but is that like a user base you think about?
Yeah, I guess one thing I've noticed by introducing like a reactive experience to an ecosystem like Python, we do have users that are, trying to build, like they've sort of maybe learned a little bit of Python in their education, and now they have sort of a toolkit or that background with that coding language, and now a toolkit that allows them to make like programs a bit more interactive. So we do see things like games, I guess, being built inside of Marimo. But I'd say in terms of like the scope of where we are taking the project, it's definitely oriented around, generally folks have some unstructured data. They're going to like load it into memory and like, do something with that data. Either that be, perform some kind of analysis, or maybe do some sort of like presentational scaffold into like an application.
I guess like more concrete. That just to remind me of like, processing? It was like an art, really like a framework for doing kind of art explorations, and it feels like you could definitely drive a reactive notebook in that direction as well for doing computational art. That would be a cool kind of
we definitely have a community member. I'm forgetting his name. I can share a link, but he's a mathematics teacher who has all these really cool generative like art displays that he would normally, I think historically in the past, would write these scripts in matplotlib that demonstrate some sort of like a lot with like fractals, and now like being able to grab that plotting library, add a slider, and now you can like play around with that fractal. So we definitely have like art that's being generated, but often to like demonstrate some sort of like mathematical concept, or something that is sort of, I guess, like coming from more like the education side. Yeah,
I think hearing your response made me think that, surprisingly, a lot of problems are data problems, whether it's like music or art or different things. So I could see, I wouldn't be surprised if Marimo is used in all kinds of use cases that aren't like a data scientist crunching numbers like for their company. I will say I love the app mode. I feel like app mode is really killer to be able to go from a notebook where you're analyzing to this kind of like display, more dashboardy setup. Has been super cool. And that kind of made me think of one question. Hadley, do you use much notebooks? I know like in R, it's a bit less common. I'd be curious, maybe just for context, to hear some of your experience.
I think like I've never really gotten notebooks. I kind of feel like there's this, like when you start learning, like you either learn a tool like R with like a REPL, and you learn something like R Markdown or Quarto, where you like kind of render a document, or you go down the notebook path where there's kind of like intermixed things that you run and text, and it feels like once you go down one of those paths, like the other path just feels like weird and unnatural, and like it's not like it. Obviously, like people can be successful in either path, but I don't know if I've ever met anyone who's like, oh yeah, like I really like R Markdown and I really like notebooks, and somehow I've like synthesized them in my head. So like when I've played a bit with Marimo, and it just felt like really strange, especially the fact that the the order of the chunks in the document does not matter. Like it's only the order of dependencies between them, which that did feel a lot more like this literate programming, which, to be honest, I mostly have like negative feelings about based on LaTeX documentation manuals for LaTeX packages, which have either of you used LaTeX?
Oh, not for so long. Yeah.
I think like the documentation packages for LaTeX, and because I've written this literate programming style, which explains how the whole thing works, and you're like there's now a 400-page PDF that explains how this tool works, and you're like, I don't care, I just want to know which option do I need to set to do the thing that I want. So I was like, I don't know, I felt like I got burned by literate programming on LaTeX package documentation.
Yeah, I would say like the extension of or having like having reactivity and that the cell order does not matter, like introduces its own set of like new sort of like trade-offs and problems. But those have been things that we've tried to address more through like having different debugging tools inside of the notebooks. If you're like focusing on a cell, we have this thing like actually inspired from observable that's like a mini map that allows you to sort of jump around and trace back to like where like the dependencies of that cells are. So you can kind of like focus locally, I guess, on like the step of your analysis that you're working on. But there certainly are trade-offs to having, like an a document that you can read top down. We don't force you to move around your cells, so you could write your notebooks in that way. But we also think that it provides this freedom for when you want to do something in maybe take your notebook in a direction that's more like an app mode. Now you can move around those cells, and you haven't had to like switch tools. I think prior to working on a reactive Python notebook, when I had some sort of like data task and I didn't want to make like a website and I didn't want to do like a script and maybe it was going to be like presentational, prior to like starting on that problem, I'd have to choose like think about the tool that I would want to use to like start that. So it'd be like, oh, maybe this will be a Streamlit app, or maybe this will be a Jupyter notebook, or I'm going to start working on this library and I'm going to like prototype that in a notebook. But as I'm working in a Jupyter notebook, I like started to get this itch where I'm like, I got to move this code out of this notebook because like I'm not going to be able to like use this from other files. And I think Marimo provides a really nice on-ramp for like starting with data problems, and then a lot of different off-ramps depending on like what direction you want to take those. What direction you want to take the work that you've done inside that notebook, and let's sort of like package it up for someone else.
I guess one thing Hadley said that y'all reminded me of is that I guess our users do have the problem. Trevor, you mentioned like having to switch or choose the right thing for your problem. Like I have noticed one thing I've demoed Marimo. All right, we got this to people at the company because I'm a huge Marimo fan, and it is funny. Like our users, sometimes there's this funny switch of like you're analyzing data, so you're using a tool like R Markdown, or you're producing plots, but then when you want a dashboard, you kind of have to like copy your code into a dashboarding tool like Shiny, and so there's kind of this funny moment like when will I turn that dashboard knob? And I feel like Marimo, one thing that it has been really nice is it's the same thing. Like you're in the notebook, you can interact with the data, you can plot it, but then you could switch to app mode, and actually now it is like a reactive dashboard.
Yeah, it's a really interesting framing, because I think we have tried to do that at various points, like through R Markdown. Like you can do dashboards in R Markdown, and we experimented with a way of doing like Shiny apps inside R Markdown, but they just never really felt quite right. Like it's an interesting trade-off though, because it's like there is some, like it's nice to be able to like not have to decide what the final output is going to be at the beginning, but it is sometimes your final output like shapes the way you think about the problem so much that you do want to like kind of commit to something up front, which I mean, obviously you can do that with Marimo. Like it's not like you can't commit to one thing, but it's just that's an interesting problem to tackle.
Yeah, and I think, I mean, again, there are like certainly trade-offs as well of like deferring that choice like upfront, like because of what you said in terms of the way that, your tools and approaches like shape the way that you think about the problem. But I think what I found increasingly was, I'm biased because I started working at Marimo, but like prior to that even, was that a lot more problems felt like well suited for a notebook compared to like what I'd been using them for before. And so I find a lot more things now where I'm like, oh, that could just be a notebook. And maybe one day I'll come back to it and start and pick up where I left off there. And it could be a hybrid of like almost like an app, or like, I work on this project called Anywidget. There could be like an Anywidget that I've thrown in there that I'm playing around with some data. And it doesn't have to be like stringing together a lot of different files or projects. And it can kind of just all like live in this like this thing that resembles something closer to like traditional software than like a notebook, but is also not like a proper like program, or it isn't just a clean Python module. Like it has like this runtime and everything as well. So
I mean, I think one thing we should say, like to be explicit, is like traditional Jupyter notebooks are like a JSON file, whereas Marimo notebooks are just a Python file with some like special annotations, right? So you can just execute them like a regular, like they're an executable thing, not like this weird kind of like mix of a bunch of different things, which makes them like very different to traditional notebooks.
I'm actually so curious to hear a bit, maybe going back to maybe to take a step back and go to your like journey into Marimo. And I don't know if being a Wisconsinite has something to do with it, but I actually like, I was so curious because I noticed you mentioned you're like from Wisconsin. As I understand, you went to Kenyon College in Ohio, and then you jumped to Cambridge in the UK, and then back to the other Cambridge in the US to do a PhD at Harvard. I'm so curious to hear a little bit about your, like the places you've been and some of that, because you've been so many different places, starting with Wisconsin. Tell us a little bit about the places you've been and how you've liked them.
Yeah, okay. So I grew up in the Midwest. I'm from Eau Claire, Wisconsin, small-ish town. Like it's now, I feel like as I'm zooming in on a map, or if I'm flying over Wisconsin, you'll like see Eau Claire now. So we're big enough that it'll be one of the few cities that like pop ups. But it felt very small, like growing up there. And then I went to like Kenyon College was in Ohio. It's like very small liberal arts college, where I studied chemistry and I swam competitively. So I was like definitely in like the natural sciences, but did not really, work with computers that much. I mean, I used computers. I made websites for fun, but I didn't for my own like research. I was very much in a wet lab doing like organic synthesis. So it felt very distant from the type of work that I ended up doing for my research.
Is there a lot around it, like in Kenyon College?
Yeah, so Kenyon College, it's about an hour outside of Columbus, Ohio. So there are about 2,000 students. Being a liberal arts college, like I got a Bachelor of Arts in chemistry. So I studied like humanities and things outside of like the natural sciences as well. And I think it was just a really nice place to have faculty that were like very hands-on with like learning. So like, in contrast to going to some of the places where I ended up for graduate school, like the priority at that university or at Kenyon College was like having faculty that were very like engaged and like trying to get folks into research. So I had, I think it was my academic advisor had a lab, and he was like, "Hey, if you want to like do some research, you should try it out." And it sounded interesting. So that's sort of where I started my research career, I guess. Yeah.
And then from there, you went to Cambridge. Is that right?
Yeah, I tell you, it was like a bit of a journey, I guess. Like because it was such a small school, I would like apply for various like summer research internships, and I ended up taking like an internship in St. Louis, Missouri, at the Danforth Plant Science Center, and I was doing a lot of like wet lab kind of like molecular biology stuff, but they ran this workshop with computer vision, and that was like the first time that I used like, I think it was a Python program called like OpenCV. They gave us like a Raspberry Pi, and I remember I was like, that summer I was imaging a lot of like Arabidopsis, which is this model organism, and I was measuring all the apertures by hand. And then like we ran this like computer vision program that like I saw like kind of automate a lot of that. And I think it was like kind of this like revelation of like, oh my gosh, like I should figure out how to use this stuff. but also it was like kind of interesting because it was a very visual like output. Like you could kind of see where it measured things on the actual images, and being able to like, as a human, like look and observe that, you could kind of see where the algorithms would like fail, being able to actually like highlight a region. And so I think that's, I mean, in retrospect, it's easy to like construct some narrative of when I started down this path into like visualization, but like that was probably somewhere where having the somewhat like web background and like also this like science background, and seeing like how the ways that, you know, visualizations can sort of surprise you or like confirm like something that you suspected in the data. It became kind of this interest of mine to see like, yeah, if you know, if I am applying algorithms or using computers to like assist my help myself automate some of this stuff that was really tedious, like, are there ways that I can bring myself into the loop to make sure I'm like pretty confident about like the application of those tools?
Had you done a lot of computer programming up to that point?
Not really. Yeah, I mostly like web, HTML, CSS, JavaScript kind of stuff. And then after that summer, I think when I went back to doing more research, I started like trying to use, actually R was the first programming language that I like really sat down with to learn for data analysis.
Never heard of it. Yeah.
Yeah. And then I think I just got really interested in, like software generally for doing data analysis. And that sort of led to, I guess not really like a total pivot, but switching into like looking more into doing like computational research rather than like sitting under the hood with a pipette was sort of the direction that things went.
And then from there you went to Cambridge to do a master's. Were you were you thinking of going like the academic route, or kind of where were you at that point?
Yeah, I think at that point I was interested in doing a PhD maybe at some point, but because of my background, like I really wanted to spend a little bit of time like doing some software stuff or like data or spending time improving my maths and sort of like becoming more of a data person maybe. So that was an interesting like avenue, I guess. It was sort of like a 1-year master's, and then after that I joined into like a bioinformatics computational biology program for the PhD.
How'd you like Cambridge?
Yeah, it was really interesting. I mean, like coming from a very small liberal arts college and then also just being like in the UK, like there are a lot of differences. Also like a lot more European in terms of like the population that was like at the school and also in the program. So that was, I mean, probably the best part of that experience was we had a very small cohort and just making like very close friends that now are sprinkled kind of like throughout Europe. But I think it was a much different type of institution than like where I went to undergrad. So I think it also like taught me a lot about, you know, priorities in terms of research or like academic priorities for faculty at different universities.
There's something interesting about, I feel like, just all the places kind of you bounce between. It seems like a big cut of both like American Midwest and like the UK. So it's interesting to hear about.
I mean, I had to wear like a gown sometimes to like dinners at Cambridge, and that was very like, I remember not even like thinking I didn't need like a suit or something, and then I was really happy that I brought one because we oddly were wearing it a good amount. So
that actually reminded me, like my dad did his PhD at Cornell, and he had like this part-time job, like checking that people were wearing their jackets to dinner.
He was like jacket police. Is that?
Yeah, like the jacket bouncer. Yeah.
And then I guess you mentioned, so you did your PhD at Harvard in the what was the lab called again?
Yeah, we're called the High Dive Group now. When I joined, the lead of the lab is Nils Gallenborg. We rebranded at some point, I think, to like but we're like a visualization group. So the way that the research that we worked on, where we have a lot of close collaborations with like experimental biologists in the department or outside the department at Harvard. And then we kind of work with them to understand like their data problems and see if like visualization, like, if visualizations could help or like really connect folks to their data. I think a nice thing with a field like biology is that a lot of the data are very abstract. So and like new types of experiments come out in which you like acquire and like new information. And so it's like kind of this nice, interesting pairing for folks that are really interested in developing new visual representations, because you have this really abstract data type that you're trying to, come up with new ways to represent that are effective for helping understand information.
Yeah, I see. So it might be less about tools necessarily. Like rather than tools for visualization, you could focus on like what visualizations would kind of like help people work on these problems or like visualize the space well.
Yeah, I'd say like a pretty like classic example would be something like a genome browser. Like that's like a very like the types of visual representations in a genome browser are like well known. Like it's a lot of bars and like dots. But then the type of data behind it and like the idea of like overlaying all these different tracks and it being like zoomable and like panable and like also just laying out the genome like linearly, like that's like a chosen representation for that information. Although what I will say is like from the visualization community, like when I joined, I was super excited about, I'd gotten into working on, interested in visualization. Some of my first like open source contributions were in sort of like visualization libraries. And I think I was just motivated to have something that like kind of fit my background, but where I could study visualization and work on it. And it seemed like the focus of that community is really on these like novel representations because that is where like interesting, I don't know, like that's kind of like where the field was. And so the types of like applications or the types of software that we would work on would resemble like a lot more like monolithic like software applications. Like it's, hey, we built this like viewer for this. And what I found over time was that like we ran into all these practical barriers where like that might make a really interesting like visualization paper, but like the field is sort of interested in these like new representations, but things that are kind of like boring to the field now, like still are not being used by like practitioners that like have their hands on data. And I think that that's where I really started to think like, or I took for granted like the cost of the tools that we use. Like if you are like, I use this tool and I work on my data in it every day, and then I come to you and I say, I made another tool for you. It's like, okay, does that complement my workflow? Are you asking me to like throw out my previous thing? Like, how do I get my data into that? Like, these are all just questions that you start to have to either answer with software in that application or like workflows to get data in there. And I think I just got kind of frustrated in this feeling that the community that felt like it had solutions, and like there was like kind of this disconnect back to like the folks that would actually benefit from using them and in understanding their workflows in real ways.
I remember going to a Viz conference a while ago and having this just like really strong feeling like these people were like, this like haute couture, like they're creating these amazing kind of bespoke pieces of art that's tailored to one person. And I was coming in and I'm like a buyer at Target. Like if I can't get this on the back of 1 million people, like who cares? Like it's just such an interesting like difference in perspective. But it feels like that there's much more emphasis these days on like actually shipping stuff that people like more than like the one research group you're carefully collaborating with can use.
I think I started to think about it a lot more too, is like, I think the reason why it's not like that community set off to like build these like only specialized applications, but like, in writing my PhD thesis in the end, I tried to think a lot about like why visualization software is kind of different from like other software. And I think a part of it is just that it touches so many pieces of the software stack. Like it has like a backend and it has like the actual UI layer. So like, you can shell out to different commands from a lot of different applications, but it's really hard to take like this visual thing that was built one way and stuff it in another one if they're built with like totally different technologies. So yeah, I think I just started to focus, maybe there are ways that we could improve our software practices in such a way that like we could try to standardize a little bit more how we're building these visual representations, such that we don't need to build like the all-encompassing tool that does everything, but like maybe we can layer on like just the visualization layer into an environment where someone already knows what they're doing with their data. And that led me to, looking at notebooks, because that was something that I used a lot for working with data, and also our closest collaborators use Python notebooks. And then, also there's a way of extending Jupyter notebooks with something called Jupyter widgets. And that was sort of how I started playing around with this idea of taking, web-based visualizations and embedding them inside of the environment where people had their hands on data rather than saying, hey, here's a new application. And sort of giving that feeling of, hey, if there's this library, pip install it and get going, rather than like, oh, go to this website, download the software, like, run this script to export into a particular file format and then ingest it.
I mean, the other thing that did change is like you could create, like now you can create high performance visualizations in a web browser. And 10 years ago, that required like, C++ code, or 20 years ago. Like that is another, like that's one of the reasons that it's so much easier today to like distribute this stuff.
Yeah, that's fair. I guess to the notebook point too, it's interesting because Trevor, you mentioned like all of these applications had to worry about how does data come in. And I guess if you look at it from the notebook side, it's like this kind of substrate can handle that across everyone. And it sounds like you're saying if you just focus on the visualization part, the notebook can kind of take care of all these activities that every single bespoke app repeats, essentially.
Yeah. The concrete example I like to give is like, imagine that you have an application that like renders points, like a scatter plot application. And someone's like, it's like, okay, how do I get my data into that? It's like, oh, okay, we take a CSV as input. Okay, what are the columns of that CSV? And then it's like, but what if I had a TSV? Or what if I had like a Parquet file? Or like, it starts to be that now that you're putting stress on that application to solve that layer of like, how do I get my data into memory such that I can put it into this visual representation? Versus in an environment like a notebook, you can kind of just say, my data visualization takes a data frame as input, and it should have these columns. And then there's other libraries that someone is interested or that works in notebooks knows how to get their data into a data frame. And so you can really focus on like the data types, like tabular versus maybe like multi-dimensional arrays, or I feel like are kind of like the core data types in the data science ecosystem. And then if we just build the visualization layers on top of that, you sort of reduce the requirement of the front end of having to like understand or do that massaging of the data. And instead you can sort of have a much like thinner, like actual visual representation that you are contributing.
Yeah, and then the bit that makes that work is you can now rely on you can just expect that the end user can like program, so they can like stitch together the one package that does import with another package that does visualization, which again is, like has not always been the case for visualization tools.
Yeah, and I think like the same way that you could, like the libraries like scikit-learn don't necessarily import, or I don't actually know if they do, but like have IO primitives in them. It's more like algorithms that you apply to data structures. And, how do you do that for visualizations? It's like, maybe we assume similar data structures, but we just do the visualization side and not so much of like the pre-processing.
And in Marimo, just to tie it up with a bow too, in Marimo, this is a widget. Is that right?
Yeah, exactly. So, to complete this, I guess, this thread with like Jupyter widgets, I started working on them because they seem like this useful primitive for, extending notebooks with these interactive elements. And just to be concrete, a widget is like a little bit of front end code. So something that runs in your web browser that can embed directly into the output area inside of a notebook. So if you have a cell that runs some code, now you can have like some user-defined front end code that sits there. But the really important bit is that also that code has a way of like communicating back to your actual, where your Python objects live. And so it provides this really rich interface for actually like, I can move a slider and that changes a value that actually lives in Python, not just like in the front end, like that state isn't trapped. And so, Jupyter widgets are the mechanism by which Jupyter defined, like, here's how you sort of coordinate these two worlds. And what ended up happening was when widgets first came out, you had this fragmentation of different front ends for Jupyter, where you had like Google Colab or VS Code or Jupyter Lab or even classic Jupyter. And because the web browser didn't have like a standard module system, they all kind of rolled their own system for like how you load third-party JavaScript code. And so what that meant was now every widget author like had to become an expert in like web bundlers and package managers to be able to like create something that could be used universally. So I started working on a couple Jupyter widgets. I'd been working on building like, web applications, because that's how we built a lot of the visualization tools. It just felt like a lot different type of development. Like it felt like it was like years before what I was familiar with kind of with modern web development. So AnyWidget which is the project that came out of this, was originally was just a way for me to be able to iterate very quickly on like building like more of these and make it a little bit more fun, where I didn't have to like restart my browser and like refresh everything to like see the updates. It was trying to come up with unifying like the way that you wrote that front end code more around how modern browsers talk today, and then like ingesting that in a bunch of different environments. So I could sort of solve the platform compatibility problem once, and then like just author this thing that's a little bit more portable.
Just for some context too, I think people like a lot of people think of AnyWidget today, but yeah, having lived through the shift to AnyWidget, yeah, I can't overstate how convenient it is to have something run across all these different platforms. That I do feel like that juggling was real, of figuring out like I can run it in the Jupyter notebook. Now I've done the work to figure it out for Google Colab, but like to have it in one place and not even have to worry about that is so convenient, seems like.
Yeah, and I think also like, and when I've used notebooks for prototyping like Python code, like maybe to speak more concretely, like I use notebooks to prototype code because it's a way that I can run little snippets of code and try them out. But in order previously to like even just experiment with the idea of like a visual output, like a widget, like you'd have to like create a new Python project and like kind of like link and like start this like build process in Bundler. And so like you couldn't just like play around with, hey, maybe it'd be fun to like draw these things in the web and put them there. And that was probably the most like exciting thing to me originally with AnyWidget, was just the fact that inside of a notebook I could like start playing with both front end and my Python code together, and then kind of get these proof of concepts very quickly without having to like start a whole new project.
So does Marimo like extend the Jupyter widget protocol in some way, or is it just much better because it's not reactive, so when one widget changes the others can update automatically?
Yeah, that's a great question. So part of this is that AnyWidget itself defines a specification, not only for like the people that author widgets, but also like what a host platform has to implement in terms of APIs to support widgets. So if you're using AnyWidget in a traditional Jupyter notebook, that protocol layer is like the host platform. AnyWidget, the library, like plugs that in so that you can just load them and like run in those environments. But inside of Marimo, we actually like natively implement an AnyWidget API to like support the AnyWidget protocol. So there is no like Jupyter machinery inside of Marimo, but they do support AnyWidget. So this thing that sort of started originally as a way for me to be able to author like traditional Jupyter widgets, and now is like if you author them there are even more platforms beyond Jupyter, because if they can implement sort of the host side of that front end code, now you have this contract where basically something's going to load this and render these arguments, and then you can expect these APIs to exist, is basically the runtime contract.
It's been interesting to see too that a lot of tools like used to have these like catches, like if I'm in Jupyter, do this, if I'm in Colab, do this. It's been interesting to see like a lot of big tools switch to just using AnyWidget like that, from that kind of like if-else block of like what environment am I in. But from what you're saying, Marimo also uses AnyWidget as kind of its native like widget implementation. Is that?
Yeah, if you want to make custom interactive elements, Marimo has special machinery to host AnyWidgets. And then like the widgets themselves sort of have this internal state on the Python side that is currently like based off of this library called traitlets. That's just the Python side is like the AnyWidget or the machinery. And what you can do is like pluck off individual pieces of state from those widgets to observe as reactive values inside of your notebook. So I'll declare my widget. I can use a decorator that's called like, or a function that's called mo.ui.anywidget and wrap my widget in that. And that will just listen to every single value on that widget, or you can take individual pieces of state and lift them off of the widget as well. And now you basically are like taking that internal reactivity and pulling those into Marimo's reactive graph. So now I can like reference a value in a different cell, and it plays nicely by Marimo's rules.
I'm curious too. I know you mentioned you've been working more lately on a marimo pair. Maybe tell us a little bit about marimo pair and the problem that solves.
Yeah, I'd say, increasingly I started using coding agents at work for doing like traditional software development. And we had like some initial sort of integrations with like coding agents for Marimo, but both from our users and like my own personal experience, like there felt just kind of something off when you tried to like do something in notebooks. Like it was like, and I couldn't really put my thumb on it at the time, but it was just like, okay, I have this data idea, and with my coding agent, I can just let it loose in like a folder of a bunch of script or on my file system and just like let it rip on a problem, and I'll come back and I'll have a bunch of scripts and some outputs. But it would, like if I tried to use like integrations I'd tried with other types of notebooks or even with Marimo at that time, you'd like the way that our integration worked then was sort of we'd edit the Python file on disk and try to like play the different changes back inside the UI. And what would happen is you let the agent go and it would just kind of say like, okay, good, I'm done. Like it works. And like it like wasn't working. There would be some like issue in the UI. And then you really felt like you're kind of like babysitting this agent, which is like a much different user experience to like working on traditional software where it's like, hey, I have these tests, go run them until you like fix the problem, right? Or like it's going to encounter syntax errors and like keep going until it like finishes up. So yeah, Marimo pair kind of spawned out of like taking a step back at how we were approaching like trying to use notebooks with agents. And I really think our new framing of it is thinking about like notebooks, notebooks and stateful environments for coding have been useful for humans to understand data. Is there a way that we can like actually make notebooks useful for agents as well for exploring data problems? And so it was not so much as like, can we use like a notebook as nice context for the model, but like, can the model actually just use a notebook to like reason and like work on a problem for a while? And that changed, that led to us like really changing how we went about like exposing our notebooks as a tool for agents.
Yeah, I demoed Marimo pair for the company at like a work week because the fact that in Marimo, it can just, the agent seems to be able to do anything, kind of like anything I could imagine clicking, it seems like the agent can do. There may be some limitations, but it's been so interesting to interact with.
Yeah, I'd say like previously, or the way that I'd read about using something like MCP is like it's, model context protocol is this way of like taking an application and like exposing it to like your agent. And the way that we were using MCP before was kind of like allowing the agent to query the state of the notebook. So it'd be things like, what are the cells? What are the contents of the cells? What are my variables that are inside of the notebook? But then what we realized was like, when the agent would take an action like writing or mute, like doing something in the notebook, it was using its existing tools to edit a file on disk, but it never got feedback for like, hey, did something go wrong? Like in that same execution channel. So it was kind of, so what the agent would have to get good at is like making a change and then querying the notebook over and making a bunch of serial queries to be like, did something go wrong? And what we changed inside of Marimo pair is we basically got rid of like all of our tools. And we just have one tool that is like run Python code. And that just runs Python code in the Marimo kernel. And there's a hidden like Python API in there where the agent is able to control the Marimo notebook and ask about the Marimo notebook itself. And so when it does something like hallucinate a value or redefine a variable or something that doesn't play nicely by Marimo's rules or Python's rules, it just gets feedback in that same like turn that says, hey, you need to change that. Like that's not working. There's an error. And then it can keep going. And that ability to, I think, have both that read-only access and like see the effects of the mutations, like a very similar way to like when you edit files on disk and then run the scripts to see if they, exit code 1 or 0. Now the agent can do that at the cell level. And that I think allows for this ability for, the usefulness of notebooks is that you can iterate very quickly. And then when you try to like give agents to them previously, it started to feel like, okay, but the agent isn't being very productive in this environment. And I think that was sort of the missing piece was like, how do you give them feedback in that same execution channel to seeing, what you're seeing so that you don't have to sit there and tell it that something went wrong.
It is interesting that like data exploration is like so stateful. Like when you think about like traditional software engineering, like you run your unit tests and those are all designed in such a way that you start from a fresh session, they run and you get the results back. But like that just doesn't work for data analysis because it's so iterative and like, yeah, you want to be able to look at the state of the thing you just did. And you don't have to rerun the whole thing from scratch every time or figure out some complicated like caching mechanism. You want to have this like long running persistent session that records like what have you done to the data. It's interesting.
And one like interesting property I think of having a reactive kernel is that we don't allow for these sort of so we don't allow for things where you like can, you know, inside of if marimo pair, if the agent chooses to change a cell upstream, it will see the effects of like the downstream cells of making that change. So it sort of adds this extra layer of guardrails beyond just a normal Python REPL, where in order for the agent to like continue on a problem, it has to check cells into the notebook and define variables. And then each of those cells has to play by Marimo's rules. So it's almost like, you know, traditional software development is very stateless, but your state is kind of like your file system, right? So you like version that over time, and then it's running these like scripts on top of this state that you version over time. And I think very similarly, we wanted to provide a experience like that in a stateful environment with these guardrails around like how you have to check those cells in. So, you know, in marimo pair, you can't check in a cell that redefines a variable or something. So it has to play nicely by Marimo's rules. And so sort of as a side effect of the agent exploring a problem using marimo, you get like a reproducible kind of like execution flow.
There's a downside to that though, right? Like what happens if like the thing at the end of the very end of the reactive graph takes like a minute to run? Like how do you, like I assume marimo must have like tools to like when you don't want things to run all the time to like opt out of that.
Yeah, so the contract in marimo is that what you see on the screen is a representation of the state in the kernel. And so you can turn off reactivity or disable individual cells, and they will just show as being stale. And then you have to like manually execute them. So if I turned on like lazy mode, then the agent would get feedback saying you need to rerun these cells, but then it could go back and run those cells.
It's interesting. And what you're describing, I think, for the agent, as I understand, is marimo code mode. Is that right? This sort of secret backdoor into marimo that an agent can use to basically like create cells or edit them. And I think another thing you mentioned is like the connection to marimo that like, is it right if the agent like deletes a cell that defined a variable, it's like the variable itself is removed? That's kind of part of the maintaining like a fresh state. So it's like, in a way, it kind of like locks in the agent into having like an up-to-date environment. And I don't know, I thought that was really intuitive that like if I as a human also deleted a cell that defined the variable, I would also kind of want it to go away. Like that's a really classic human blunder to like delete the code that made it, but still have it like floating around in the environment. That seemed like kind of a neat contract to enforce, that if the code's gone, that variable is gone as well.
Yeah, it's a hidden Python API that the agent, like if you read the docs inside of marimo, it's like, do not use this like yourself.
If you're a human being.
If you're a human being. And part of that is that we don't, in comparison to other APIs that we have inside of marimo that we want people to like depend on, like code mode was something that we've like refined over time and we're still like changing. And that's part of that is because because it's used within these sessions, the agent learns about like what APIs it has available and how to call those in that session and that's a much different contract between like a model and like software versus like two pieces of software where you have like versioning problems and like you really have to make sure that they, like if someone was building around code mode that was outside of using agents, like they would get very annoyed with us when we made breaking changes, versus the model basically gets a new version of marimo and it has new capabilities, or maybe we fix bugs and it just calls those APIs and can sort of chug along inside the notebook.
Presumably code mode is what the marimo UI uses behind the scenes.
So most of marimo's UI is driven through like the front end, which is like JavaScript code. So we've had a lot of like it's this message. I mean, to get technical, it's like this message passing system of like edits going back to the kernel. You have some piece of state that you're updating. But really, we had to introduce like a Python API for driving Marimo notebooks because which we didn't really have before, and that made us changing a little bit about how our document model worked. So now you can like drive it from Python, or you can drive it from the front end, and they can all like sort of share that state. But really, the reason we were able to do that originally was just because our kernel is in Python. Like, so when I first worked on Marimo Pair, the first thing I introduced was just the ability for the model to like run Python code in the kernel. And that let it do basically everything that was like read-only inside of Marimo. So it's like, we had this big set of MCP tools that were like, list my data frame, list my variables. And now it's like, okay, get rid of all those. You just write the Python code you want to like cat out a table, like print the columns. Like you can discover APIs, like just call Python the same way. If you're running an agent and you see it using Python from the command line, it's like running scripts like very quickly. But then I think the first thing I did was like, okay, so show me a notification in the UI. And I saw it like try a bunch of different things. And then finally it found like one API where it like toasted me a notification. I was like, whoa, okay, like how'd you do that? And then like we kind of like looked back through the code. And so we started to then think about like what types of things would you want to drive from the kernel? And then we hardened those behind like a Python API that we could test, and such that, you can have high confidence when the agent doesn't have to like get the right sequencing of notifications. It just calls an API, and then we replay those notifications to the front end and also make sure the kernel stays up to date.
Yeah, it's such an interesting approach. And also, I do think it's interesting to hear it in contrast to like the MCP or tools. There's like a lot of ways to kind of carve this up.
But I think we've like like in the early phases of like MCP being a thing, everyone was like, let's make a bajillion MCP tools. And then kind of discovered like, oh, actually LLMs are like way better at writing code in an existing language than trying to figure out some like bizarre, novel set of tools that you've created. And now like, MCP still as it plays a role, but it's so much more powerful just to give it a few like tools that let it write code and do stuff. Like that's really, really powerful.
Like we basically allow it to do, like we still have a way of running Marimo Pair through MCP, but there's only one tool and it's like executing Python code. And I think the other thing that was non-trivial to me, that when we changed that way of having many tools to like one very sharp tool, is that programming languages have this, ability to like compose different primitives as well. So not like you don't have a bunch of different tool calls. You could actually in one execute code. It could like look at the notebook state. It could like create multiple cells, delete cells. Like those don't have to be individual transactions that you replay. And instead it's like you can leave it up to the, creativity of the model to figure out how to string these things together to accomplish the task that the user wants to do inside the notebook.
Yeah, I see that a lot when using Claude to write data analysis code. Like it will write the R code to answer like 3 questions at once, rather than having to, like ask first, then ask. Like what is the data? What are the data frames? What are the variables in the data frame? What are their types? It just does that all at one swoop and gives a bunch of information back to the model.
And I feel like just to set the stage too for what, like when I used Marimo Pair, that there's a skill, like essentially it was so interesting to be like, okay, just use this skill. I was using Claude Code from the command line, just like plug it in, and that Claude Code actually could, and this isn't a surprise, install Marimo, essentially fire it up on my computer, tab opens in my browser, and then just starts driving Marimo. I feel like that was such a kind of eye-opening experience to realize like there's another world where Marimo said like, hey, set us up, run the agent from inside Marimo, and it could do some stuff. But to watch it actually like realize that we needed a blob on the outside, like even running Marimo, opening it, and orchestrating it was a really interesting experience to see. And the other thing I'll flag, and correct me if I'm wrong, is that Claude Code is essentially using a CLI, like a bash tool. Is that right? To basically like ship this Python code in, this Marimo code mode in to run in the kernel. Is that right?
Yeah. So if you install the skill from like GitHub, which is the way that we recommend doing it, you'll get a bash script that the agent can call that's called execute code. And behind the scenes, what that does is it pings an API endpoint on Marimo that we have set up that then replays or kind of maps that HTTP response back to your standard in, standard out, standard error, and then exit with an exit code of 0 and 1. And what's cool about that is if, so we have a cloud-hosted version of Marimo notebooks called MoLab that runs like, where you have a kernel that's running in the cloud. And because this is all done over HTTP, you could actually point Marimo pair to like talk to a remote version of your Marimo that's running. And then you don't even need to have Marimo installed locally. You just need curl and bash scripts. So then you can be using Claude and like you're driving a remote notebook as well. So in terms of like the distribution ergonomics, that has been like really nice in that you can sort of like reduce the system dependency based off of like where people want to be running the Marimo instance.
It's interesting because because you can also do the opposite, right? You can provide a CLI, like you could have a Marimo CLI, and if you call Marimo agent, then that produces the skill file that tells the agent how to use it. But you distribute the skill and then it gets the kind of CLI from that, as opposed to distributing the CLI and that gives the agent the skill.
Yeah, we've definitely found, inside the Marimo UI, if you're on any Marimo page, you can click in the top corner and then it says pair with an agent. And we give you this little snippet that you can run in your terminal that like says use the Marimo pair skill and like, toast a notification and like, here's where the notebook is running kind of thing. And that is kind of the nicest experience I found to being able to launch it, is just like you spin up Marimo, then you click that and you can sort of be confident you're connected and keep going.
But how does that get the skill and the bash script onto your computer? Is that just like a curl command and then you sh it?
It's a sub command in the Marimo CLI that like basically is like a prompt that says like check to see if we check to see if you have the skill installed. If you don't, then we'll like prompt Claude to like go get the skill and like have you install it. But if you look at the Marimo pair skill, it also is like very uncoupled to like the code mode internals. Like it basically tries to orient the agent around like the things that Michael was talking about. Like, if a user is trying to do something with Marimo, like what's a nice path forward, and like trying to help them like spin up Marimo. And then the second piece is basically telling it, you have one tool, and then there's this thing that's called code mode. And like when you start a session, go look and see what code mode is in that instance of Marimo that you have. And so because we can ship changes to code mode, baking in like those API invocations in the skill itself would kind of lead to this versioning problem. And instead, what we've been able to do is like version the two independently, where we just say, here's the skill, and then we can ship upgrades to Marimo, and we don't have to worry about the two sort of like drifting from one another.
It is fascinating to me how agents going to change the API ergonomics. Like one thing I think it's kind of interesting and surprising is like, I would say on average, like agents are way better at reading error messages and actioning them than humans. So like good error messages have always been important, but they're almost more important now because you can assume that an agent will actually read it comprehensively. And if you have a good suggestion, it will follow it. And then that can make like APIs like way more discoverable on the fly. Because as long as the agent kind of gets somewhere in the vicinity, it then gets like pointed to the right place.
Yeah, I'd say we've even thought now about, as like when you're in a code mode execution, having ways of streaming like agent only logs or like suggestions. So there's like a code path that goes down that like, hey, you're probably like trying to do this thing that doesn't really work, or like this is a better option. Like that's something we could like from Marimo say, actually use this API, and like that, like the agents do follow that really well, because you can sort of do this like in context learning almost of, actually do this instead. And as you were saying, they follow it quite well.
Because the other interesting technique is to just implement the API that the LLM hallucinates, which I think is also like a fascinating
I would say
API
that was how
technique.
like the early development of code mode was I had sort of this idea of what I wanted that API to be. And then we ended up introducing a skill, or I wrote a second skill that I called retro pair. That would be if something was like really annoying or the agent stumbled a bunch, like that skill basically looked at the logs and tried to like diagnose like some stuff that was like kind of annoying or like things that were hallucinated. And then we would have this like internal Slack where we just share around like, hey, this happened, hey, this happened. And then that was a nice starting point to refining the API for our team, prior to us having like better evals of like how code mode is being used.
Yeah. I love it. I don't know. It's so silly. Like I think a lot of people won't understand this, but I'm obsessed with code mode. So I really appreciate you share. I just feel like the design, there's something so reasonable and nice and composable. It's such a like small set of choices, I feel like, but it's really cool to see how they add up and basically like thread the needle between like what agents do well and what people do well.
Yeah. In fear of getting maybe like a little too technical on it, but it might be interesting to this audience. Part of the way that we implement code mode is within a async context manager inside of Python. So that's like, if you ever use like with, the with context manager, with some invocation of code as this other, you get back this value variable that then you can call with inside that block. And what we actually do is that as the agent's working, we don't actually perform any of those operations within the code mode block itself. They just are kind of like queued as a thing that the agent would like to do. And then when it exits code mode, we kind of see if we can simplify that invocation of code and replay it in such a way, or we can do things like we can check the code that the agent's going to run prior to actually running it so that we can have high confidence that each transaction is like okay prior to like actually playing it back in the UI. And so in terms of what Hadley was talking about of giving this in context feedback, if the agent tries to do some sequence of API calls that were like, whoa, you shouldn't do that, we can actually just give it feedback that says you need to reverse or like change something about the API call. So we have this like little like level of indirection that allows us to inspect the thing that the agent's trying to do and like view it as a holistic chunk, and then try to give some sort of verifiable checks that tell the agent like, oh no, don't do that or do this.
You're like a SQL query planner, but for notebook updates, basically.
Much more simple, yeah.
So you said a lot about code mode and how like humans and agents can work together, or even agents can work really effectively with Marimo notebooks. I'm really curious about from the other side. Like I saw that you all for a conference wrote Beyond the Shell, like this pitch for essentially like why should an agent go beyond the shell? Like a lot of us are using Claude Code on the command line, and a question might be from the other side, like why should Claude Code choose Marimo to do data analysis rather than running like bash commands or Python scripts? Could you say a little bit about that? Like what do agents get out of Marimo, would you say?
Yeah, that's a very fair and good question. So, and something we've been thinking about a lot, working on notebooks, right? Like almost putting this existential question of like, should we work on notebooks? And I think similar to how, we've got like humans have reached for tools, like clearly notebooks or some sort of like live programming environment has been useful for humans to work on data problems. And I think we're sort of continuing the pursuit that if we get the right ergonomics, these can also be useful tools for agents to work on problems. And part of that just comes from this like ability to iterate on the problem, right? Like being able to, a lot of like data tasks involve this, I think, greater interplay at times between like, the code you write and the inspection of the outputs and then deciding what to do next. Like it can be a little bit more hands-on in the type of work that you're doing, and giving the agent the ability to the environment that it's doing that work in, bring in the human with like a very rich canvas, right? Like Marimo or Notebook itself has the ability to embed these interactive outputs or just plot like static plots, right? Where different steps of that pipeline, the agent could say like, hey, take a look at like the data frame here, or I want to pause here and like go before I go on to the next step. So for one extent, I think it's a really interesting substrate for human, like the notebook itself is a really interesting substrate for the humans and agents to sort of like discuss together. And the other is, I think, is really this idea of like you're sort of pushing the model's thinking into like code and having this like artifact that comes out of that like session that you're working that resembles like what happened in that discussion. So yeah, I was talking with a colleague about this recently, but if you, let's say I have like a problem at work and I'm working with some data, and I have like an instance of this problem where I open up my chat and I like start working on I don't have any extra tools. It's just the file system and maybe some Python and stuff. I might solve that instance of that problem with like a directory of some scripts and some outputs and a set of logs that describe like what that conversation was. But the next instance of that problem, the starting point is maybe like I point at that folder, or I point at like and that conversation history from before. And by like sort of forcing some standardization of like what that reasoning was and that artifact that like came out of that session into something like a notebook, I think that can be a really powerful way to like bootstrap like solving instances of those problems in the future, such that maybe you actually, the next time you work on that type of data task, you start in a notebook, and maybe you work really hard on a notebook that solves like a general version of that problem, such that in the future, if you're picking up sessions and it's just editing a couple cells to like get back to like a very like similar type of output. So I think by having this, like artifact from like these interactive sessions with talking about data that do have the properties of code because it is code, like that is a really interesting property of like, doing data work that is like more reusable, or sort of like a better starting point for some future work as well.
I'm still trying to wrap my mind around Claude Code just picking up Marimo on its own. Like do you think there's a world where something like Claude Code, even if the human didn't get involved, like that something like Claude Code would benefit from Marimo? Like, let's say I never read the output. Do you think that there's a world where it would benefit from Marimo in that workflow?
Yeah, well, so one thing is that these models, they've also been fine-tuned on like coding tasks on like the using the file system. So they're really good at like grepping around and like looking for things, but like that can kind of pollute context, or like you can kind of like get context bloat very quickly if it needs to like scrub around to find like different values and things. So I have some hunch that, there's been some work previously in like using Python REPLs with agents, but like you almost allow for the agent to put context in variables or in memory that then it can like choose to query back with code, such that, instead of having to look at all the values of my data frame or skim through a CSV, maybe like I'll just load that as a thing in memory that then I can query multiple times more efficiently and get back like specific context. So, and then I think, again, like if it's sort of like, what is the output of that work? Maybe if it's just for like working on a data task where it's like one-off type of thing, just letting Claude Code rip like with Python and like the file system, I think is going to be totally fine. But, if, we do have users using Marimo pair that like are like deploying a lot of like headless versions of Marimo, and that those all produce different Marimo notebooks. And then because it is that artifact, you can like spin up Marimo later and like look at what the agent produced and compare them, or like you have this sort of substrate that then is more portable, or I can, I don't have to necessarily give someone my chat history and like a bunch of files and like a PDF. I could like just give them the notebook that like the agent produced and pick up from there.
I had sort of another question very closely related, like a different interpretation of Michael's question. And that is like, do you think at all about like how in the future, like, do you worry people are just going to pop open Claude and be like, analyze this data set? And in that scenario, like how do people like learn about Marimo? Like, do you start like, you obviously you like previously, we go to conferences, we like post on social media, like that's how humans learn about these tools. Like, do we need to start thinking about like, how do we tell Claude about our tools so it uses them unprompted?
Yeah, I think I've been thinking about that a lot. And I think also like Marimo itself is a very like code first like user interface for like working with data. But in a happy future place, I would love it if somebody is popping open like Claude Desktop or Claude, Codex Desktop, and like they're asking questions with data, and behind the scenes, it's like using something like Marimo to like build up some sort of like understanding with that data, such that again, like that user is a much different user from someone like me that like knows how to write some code. but like we're all sort of collaborating on a very similar like artifact. Because I do know folks like have friends that are less technical users, but have gotten interested or feel very empowered in using like coding agents and coding tools. And some of them will take like a PDF or something and like ask to, have some hunch about that data and want to ask a data question. And then maybe it comes out with like a table, a markdown table in that chat that says like, here's like some answer, right? And if you are presenting that to someone, the thing that you want to be able to answer is that follow-up question of like, how did you get to that number? Or where did that number come from? And I don't think I'm nervous about there being some world that we get into where it's like, well, here was my chat history that got me there, or like, here was like the set of scripts that ran, and rather than like, here's the code that made that cell, or something like Marimo, you could actually, if you ask a question of, where did that label for that axis come from? If you started that whole process in a Marimo notebook, you could actually trace that graph all the way back to the beginning of like where that value changed and like change that value there. So I think having these artifacts that preserve that sort of like providence of that conversation, but in code, whether or not you're looking at that code first, or maybe you're somebody that's more a data practitioner, is it like not a code, like is it writing code in their day to day? But then the real existential question that you're asking, Hadley, is like, how do you get these tools into those environments? And I don't know, is that buy-in from like if it's something in enterprise where like they're just equipped with these, right? Like sort of coding tools out of the box. Yeah.
And then how do you make sure like all of the like monetary benefits of that don't accrue to like Anthropic and ChatGPT and like all of this open source support? All this open source work just goes unsupported. Yeah. Like how do we kind of complete that loop, like that feedback loop? And
it's an interesting one. Both asking like, what will the tools use, and like, how will like open source software kind of be preserved and supported? And also, I think, Trevor, to your point, like how will organizations decide? And we do kind of live in a world where someone could like vibe code a whole dashboard in a myriad of ways. Like, will there be benefits to building our dashboards in the same way, say in Marimo, so you can kind of crack it open and start from like a cell, or go back and look at the code and kind of see how things were made? No, I'm a huge Marimo fan. I feel like this style of notebook agents really, I liked notebooks before, but I was open to the more R way of doing it, which is very text driven. But I do feel like tools like Claude Code and agents have really kind of reignited my love of notebooks. And I think in no small part due to like Marimo Code's interface. So yeah, really appreciate you coming on. I think it's so interesting to hear about the design, like just the human part, the design of the notebook, but also everything being done for this kind of like agent human collaboration. Super interesting stuff. Really appreciate you coming on. Any last notes or things you want people to know?
Try out Marimo pair. Yeah, I don't know. I think
it's just a skill away, right?
Yeah, it is just one skill away. I do think about for a certain audience, like a skill is something that someone understands and can install, but like how do you, like more broadly, as Hadley was saying, like introduce the idea of that being like a way of shipping a piece of polished software as well. When I started working at Marimo, and before that working on anywidget, I think that my motivation around working on those tools was to try to eliminate this like distance between like people and their data. And I think that one thing I took for granted was that writing code has also been like a barrier at times of like getting to that, decreasing that distance. And so I'm personally very motivated to be in a place where my colleague Vincent likes to say, like, we're not a no code platform, we're like a yes code platform. And like, humans can write code, agents can write code, and maybe that this is like a really rich time to be playing around with, the environment in which we get closer to data and help make decisions with data.
Yeah, that's awesome. You really appreciate you coming on. And for everyone, definitely highly recommend Marimo Pair. And I'll never say the old way again, Marimo for life. So thanks.
Cool. Thanks for having me on.
Thanks, Trevor.
The Test Set is a production of Posit PBC, an open source and enterprise tooling data science software company. This episode was produced in collaboration with creative studio Agi. For more episodes, visit thetestset.co or find us on your favorite podcast platform.